Alright, so this is my Midway progress report for my AI algorithms to solve or to predict handwritten digits inputted in. So I guess we just start with the first algorithm that I have currently, which is neural networks. Right here I installed TensorFlow because I didn't have it, so if you don't have it, you can use these. I use these to install it. Then you activate the libraries. You also need Keras as a library to be able to do most of these functions. The MNIST here, this is the dataset I'll be using, which I will print them out and show you what's in the dataset. So let's just run that real quick. The MNIST dataset has training data, which has the pixels of each picture, which are 28 by 28, so 784 pixels. And it also has labels going along with them so it can learn from, which is seen down here. Oh, there we go, I can highlight it. So the training labels there, and the training labels have 60,000 examples, or the training examples 60,000. So the examples, you can't see all the data here because there's a lot of it. But the labels, the 5, so the first one out of the 60,000 is supposed to be a 5. And then the test labels are going to be different. There's only 10,000 because it has to be smaller. And then the first one and this one's supposed to be a 7. So that's pretty much what this is. And right here, I am inputting them into variables for manipulation, and so it can learn later on. So we'll do that. And now we just all I did was separate them. The like how it is down here. To input it, it's just MNIST, which is the variable, and then you take train, which is right here. So it's this list. Train here, and then you take X, and then it's taking the X here. And that's what's being put into trained image, as you can see. This whole thing. And this is just a bunch of prints of all of them, so. Network, this makes the layers of the neural network for it to be able to learn. And the first one is, the first layer has the ReLU, which is reflected linear unit. It's the size that we're putting is 28 by 28, like each image, which would be 784 pixels. The second layer here has the softmax activation, which is mainly used for classification problems, which is what's happening here, because it's trying to classify the digits, and that's also why there's 10 units, because it's 0 to 9. The next thing here is the compiler, which compiles the optimizer, the loss, and the metrics, which it measures. Give me a moment. The optimizer. This is how it updates itself. The RMS prop is how it updates itself to based on the data it's seen in the loss function, which is here. And the loss function is how it measures the performance on the training data and how it steers itself in the right direction. And the metrics here is only caring about accuracy, so it'll show up on the right over here, the accuracy of like the loss when we run it. The next part here is reshaping the arrays. This is necessary to be how the layers, so it matches the layers to be like what the network expects. So if we run this, it'll change like it literally reshapes the array. So if I show or print the trained images, you can see that it drastically changes. So this should be the first one. Yeah, so it's 1. Yeah, it's the first 784, 1, or, yeah, 1 to 784, 1 here. And this 0 corresponds with this 1. It's going all the way to 784. And you see these numbers in here? These numbers are the color of the pixel ranging from 0 to 255 of whatever image was inputted. And as we saw here, it's supposed to be a 5. And what 0 is white and 255 should be black. So we're just gonna, and we divide by 255 again to, or well, not again, but to bring it down to what the network expects, because it doesn't need the big numbers of 255, so we divide it down to between 0 and 1. So just gonna do that. These label parts here to categorical, these just matches, like, it makes the labels readable. It matches from the categories 0 to 9, and those are the only labels that there are. And this line here, this trains the program itself to be able to predict the images in epochs 5, so it's going to train 5 times, and it's using the train images and the train labels to accomplish this. So we'll run this. Oh, I never ran this. Oh, I didn't run the optimizer. I don't think I ran this either, actually, so I'm gonna have to run this. Yeah, that should be fine. Now we can see it's training, and stuff should show up over here, graphs that show the loss. It'll probably show up after the first one. Yeah. And if we want it to go for more than 5 times, all you have to do is change the epochs here. It's showing the accuracy of it guessing and the loss. Okay, so the accuracy is pretty much 99% down here after it's trained. Now it's going to use the test data to see how well it works, and the accuracy is always going to be lower with the test data because it's new data. It wasn't used to train it, so it's always going to be lower. And overfitting, yeah, basically what overfitting is. We run this. I'm not sure why there's going to be a crap ton of equal signs. I'm not sure why this shows up, but as you can see, the accuracy is lower. Not much this time. Usually I've seen it a decent amount lower, like around 96, 97, but this one was pretty high. So next one here gets the first 20 predictions from the test data, so we can run this and compare them. Okay, so I guess we can just do like the first 5 here. So 72104. Now we can what's going on here? Okay, so now we can go up to it, and indeed it is 72104. So it's at least predicting those ones correctly. So now on to what I made to input my own image. This here is an imager. You need both of these libraries to be able to work with images, or at least what I did with the images. And the image is the image I'm inputting, which is test number 2. I drew a number 2 in Paint, and I made it 780 or 28 by 28 pixels. So I'll just run this, and it'll show up over here on the right. So this is the image I made. Okay, so now, because I couldn't find anything in R to make it into the MNIST dataset format, I had to do it myself. So here I make an array of the same thing as the MNIST dataset, except I made it only size of 1 instead of 60,000. So let's make that. And let's print it. So as you can see here, it's a 28 by 28, but there's nothing in it yet, so it's NA. Now here's my for loop to input the pixels. So we do the width of the image by the height, or the width of the image by the height to make like put the stuff in the 2D array. This num variable, which is here, is the multiple of 28 for the rows we're doing. And the count is for the columns. So I'm setting num to, it starts out as 1 because R starts their arrays in 1. Right here. So that way it'll count up every time it goes through this whole portion. So the first thing in here, we're doing array num plus count, so it's getting the X and Y here. And then we're doing color at, which gets the color of the pixel at the image at the X and Y that we're currently at in the for loop. So it'll put a 0 through 255. Oh no, it's putting a 0 through a 1. That's what it does. And now what I looked up with the color at, it supposedly black is supposed to be 1 and white's supposed to be 0, but it didn't do that. So here I just flipped them so it can do it correctly. And now since it's only between 0 and 1, I multiplied it back up to be able to be divided down here. But in all the ones at least I looked at in the actual MNIST dataset, I never saw a 255. So I only put it up to 2. The highest I saw was 254, so I put it up to that. So I'm guessing whatever they made these images with, or however the computer read them when it input them, it wasn't completely black. So I only put it up to 254. Now, and then it's just to count up to get to the next column, and then I reset count to 0 outside of this loop. And now when we run this, we can print the array. It's easy to see, at least the 2, it's pretty easy to see because it's straight black. There's no fading between white and black, so there's not like anything on this 0 that's like 180 or something. So you can strictly see the 2 in the array here. And now this is the same thing as above where I'm reshaping the array. So when we run this, and then we can reprint the array, you can see it's just like what it is above, except there's more decimals. Actually, I didn't show you after the division above, so, but it's the same thing. It starts at this 1 corresponds with this 0, and it goes all the way down to 784. And now we just do the same, the predict of the array 1, and see what it thinks it is. And this one does indeed think it's a 2. And I made a bunch of images. I made 0 through 9, so I'll just show another one. We can do, let's do 9. I think this is a 9. This is only showing up down here because my window isn't wide enough, but as you can see like the circle of the 9 here, and then the straight down of like the neck. And then we can just reshape it and see what it thinks it is. This one thinks it's a 6, so, well, either I'm doing this for loop wrong, or the formatting wrong, or it thinks it's a 6. So, but it does attempt to predict images I input. Okay, now onto what I currently have for my linear regression, or not linear regression, logistic regression. This one is not fully working yet, and I'm still trying to figure it out. All these packages are from stuff I've seen online, trying to work with that I didn't have installed, so I installed them all. Same with these libraries. I think I need most of these currently. I'm going to try to clean it up once I get this working, though, and get rid of some of these if I can. For this one, I actually downloaded the MNIST dataset, and each part of the dataset, like above here if it's still showing, yeah, I input each part. So the training data is the X here, so I'm putting this specific one into this variable from the file, which is this file, and it's just the same down, or test data is this one, and then training labels is this one, and so on. I just printed them. This one's considerably shorter from what I'm seeing. It doesn't look like it needs a lot to learn, or to be able to learn from what I've seen, unless I'm doing this wrong. So, firstly, I make a backend cluster for do parallel because I'm using the parallel function in the learning function. So I need to make my own cluster, and then I start the cluster here. And now, from what I've seen, this is the only line that looks like it's really necessary to learn. So I'm just doing test data for now. This is you can make this whatever you want. And then I'm using glmnet because normal GLM only works with like a true or false or two variables. And obviously for the MNIST we're using 10. So I'm using glmnet to be able to do a lot more variables to be able to train with. In families, multinomial because we have more. Parallel is true. So I'm actually not going to run this in this video because this takes like between 25 to like 40 minutes to finish. So it's either I'm doing this wrong or this algorithm for teaching handwritten digits is terrible. So I'm going to have to figure this out, figure some way to test this easier. This prediction line here, this attempts to predict the test data final because it's using the test data from this prediction to try to train the training data, which is this line here. And then I print it out. When I do print it out, it only prints out ones, and I'm using heads, so it prints out like 6 of them, I think. But it thinks they're all ones, so something is going wrong, I'm predicting. And after that, I just stopped the cluster because I made it. And that's pretty much it for now. So, goodbye.